Welcome you all to the video lecture on 8051 microcontroller. So today we are going to write an assembly language program to clear the accumulator and then add 4 to the accumulator 10 times. So they have given the question in a very easy manner. So first we need to clear the accumulator. So for clearing the accumulator we have the instruction called CLR. So CLR is nothing but clear. So it will clear the accumulator register A. And then so we need to add 4 to the accumulator 10 times. So for example, first A value will be 0. Next we need to add this A value, that is 0 with 4, so that it will become 4. And then 4 plus 4 will become 8. Like that we need to add 4 with the accumulator for 10 times. So what we need to do, first we need to add accumulator value with 04. So we are going to add the value 04 with the accumulator. So what happens, already A value is 0, 0 plus 04. So this instruction what it will do, it will add the source and the destination value. So A plus 4 will be added and it will be stored in accumulator again. So this instruction will do this operation. So it will add this value and this value, final value again it will store in the accumulator. So already the value of A is 0, so 0 plus 4 will be added and that will be moved to accumulator A using this instruction. But this has to be done repeatedly for 10 times. So for that we are moving the count value, okay, in any of the register. So let me consider the register R0. So you have the register R0 to R7 in the 8051 microcontroller, and you have totally 4 banks. So in any of the banks you can choose any one of the register from R0 to R7. So by default bank 0 will be selected, and in the bank 0 I am assuming that R0 register. So in the R0 register I am going to use it as for the count. So what is the count? It is actually 10 times. So again it is a immediate data, so you can use hash symbol with the 10. Okay. So first of all, after adding this has to be repeated again and again. So for that we have the instruction called DJNZ. Okay, it is nothing but decrement jump on no 0. Which I have to decrement? I have to decrement this count value. Okay, so after the addition, right, after each addition this count value has to be decrement. So I am going to use decrement jump on no 0. So which value I have to decrement? R0. Okay, so if it is not 0, again and again it has to add with the value 4. So I am going to use loop L1. So let us consider loop L1 here. Okay, so now just give the overview of all the instruction. What happens? First you are clearing the A. So at the first position A value is 0. Then you are moving the value, that is count. This is nothing but count. Count value you are moving to R0. So R0 becomes 10. Okay, then adding the value 4 with the accumulator. So 4 plus 0 will become 4. So first addition A value will be 4. Then so one time you have already added. So again 9 times you have to do this operation. So you are decrementing the R0 value. So R0 now becomes 9. So you are checking this instruction, decrement jump on no 0. Whether R0 becomes 0? No. If it is not, it will go to L1. Again it will add the value A with the 4. Previously value is 4. So 4 plus 4 it becomes 8. Now R0 again it decrements. So it get decrements to 8. So again it is not equal to 0, again it will go to this position, okay, and it keeps on adding until this R0 becomes 0, okay. So once your count keep on decrementing as 9, 8, 7, 6, 5, 4, 3, 2 and finally it will reach to 0. So once it reaches 0, it will not go to L1, it will come to the next instruction. Okay, so it will not repeat, it will not go to that particular instruction. Once R0 becomes 0, it will come out of the loop and it will execute the next instruction. So now after the addition of all the values, A will be having final result, okay. That if you want, you can store in some other register and you can see that, okay. So move, let me take R1, okay, and then A. So you are moving the final value A to the register R1 after repeated addition, okay. So that is 4, if you add for 10 times it will be a 40. 40 will be moved to register R1, okay. Thank you. Thanks for watching.